Hi, everyone. I'm Matthew Vederick with Seabine Associates, Acoustic Consultants, senior consultant with the firm, and I'll be one of the ones presenting the course today, along with Keely Seabine.
Hello, I'm Keely Seabine, Associate Principal here at Seabine Acoustic, and I am joined by my lovely senior team. As Matthew mentioned, he'll be presenting with me, and I have Marilyn Roa and Jennifer Miller, who are also both senior consultants with our firm, who will be helping us to answer any questions that come up and helping us throughout the process. Welcome and appreciate your time and attention. And I guess we can go ahead and get things kicked off.
And for questions as well, well, you can put them in the chat, the Q&A. We will also, Jennifer and Marilyn will try and answer the ones they can easily through text, just as we go along. But we will take breaks kind of to answer some questions, as this presentation over the 2 hours is broken up into 3 parts. So after each part, we'll also take a little bit of a break to answer any of the questions that might need a little bit more explanation than what's simply able to be typed in through the chat. Otherwise, I'm going to turn my video off just to save a little bit of bandwidth here, but we're going to go ahead and get started.
And just for a little bit of background, for those of you who may not know us or may not have worked with us before, we are Seabine Acoustic. We specialize in architectural and environmental acoustics, and we do a number of services from room acoustics and shaping of spaces with room finishes to the sound isolation, looking at various assemblies to try to reduce sound from one space to the other. We also look at noise and vibration control from HVAC systems. We also perform diagnostic measurements of spaces that are existing that may have some difficulties. We also perform environmental noise studies where we're looking at not only how the environment might impact our site and our buildings, but also on how our building might impact the larger site around us. We also do AV design as well, especially for specialty spaces like performing arts and music rehearsal and music performance spaces. So just a little bit of intro on who we are and what we do. This material is copyrighted, and we do have the AIA credit for today. This is a 2-hour building code course.
It's the Advanced Florida Building Code course, so it's not just the AIA, but for all those looking for your license renewal at the end of this year here in Florida.
I'm going to go ahead and turn my video off now so we can save bandwidth here. So the main learning objectives for today is that we will be looking at section 1207 and looking at the Florida Building Code requirements for STC and IIC ratings for the building assemblies. We're then going to look at some ASTM test standards, American Society of Testing and Materials standards, to look at how to actually take acoustic measurements in rooms, including STC, IIC, and reverberation times. We're also going to look at acoustic systems that are required in building design and looking at reference standards, looking at appropriate language and specs, details and assemblies, and submittal and RFI reviews, as well as job site observation and verification measurements. We're also going to look at a little preview into section 1211 of the new enhanced classroom acoustics requirements in the Florida Building Code and go over that a little bit at the end.
So here we're actually going to start and look into, as Keely said, section 1207 of the Florida Building Code. And this is going to be our STC and IIC requirements that you may actually be a little familiar with or have seen before. So as we go through this next slide, we just kind of want to look at the summary here. We have two different types of sound that we're dealing with, and that's going to be airborne sound and structure-borne sound. So airborne sounds, what we think of when we think of a TV or a speaker or something like that, versus structure-borne sound is the impact noise. So somebody walking up on the floor above, or dragging the chair or the tape to move the table, they might drag it along. So those are the types of things we're going to be looking at for those kind of structure-borne or impact sounds as well. With STC and IIC, that summary is the STC 50 and IIC 50 in the lab, and a 45 rating in the field. For the field ratings, actually, these are going to be called NNIC and AIIC for the specific metric, and we'll get into that a little bit later. Next slide. So what does this code actually apply to is the walls and floor ceiling assemblies of dwelling units and sleeping units. A dwelling unit is kind of your typical, your condo, your apartment. You need to have the provisions for living, for sleeping, for eating, for cooking, for sanitation, all of that. Whereas a sleeping unit is going to be more like a hotel room or a motel room. And so this one, the definition is going to have more, you don't need quite every single one of those facilities. But a sleeping room unit or a room within a dwelling unit is not in itself a sleeping unit. So if you have a bedroom in an apartment, that might qualify similar to, or that would be similar to a hotel room. It's not its own sleeping unit. It's still just part of the larger dwelling unit. So you don't need to look at the walls for the code requirement, at least, between different rooms in an apartment or a condo. The walls and floor ceiling assemblies as well between these dwelling units and sleeping units and the public or service areas is also required to meet this criteria. So this is going to be, to an amenities space that you might have, or, if whether you have a gym in your hotel, or any of these spaces, or if you have a mechanical room, these all still require this, even just to the corridors or breezeways. And it will also require us to look at the penetrations of these assemblies. So if that's outlets within here or plumbing penetrations, have to be made sure that we maintain this criteria. The code, however, does not apply to entrance doors, so you don't need to have an STC rated door. However, it does state that you have to have a tight fitting door, tight fitting to the frame and sill. So we're going to go ahead and look at a little bit of the history of how this code has changed in Florida over the years. So here, starting with the 2004 Florida Building Codes, when it was first introduced into the code in its current format, and still the same section 1207. At this time, it only applied to dwelling units, not sleeping units. The criteria was still STC and IIC 50 in the lab and 45 in the field. So that's kind of, as we saw that summary, it's still that same criteria. And it called for ASTM E90 for airborne sound and ASTM E492 for the measurements for structure-borne sound. Then in 2010, they added the addition for masonry can be either tested in accordance with ASTM E90, or you can actually calculate it using the Masonry Society's standard TMS 0302. We'll go through in a little bit an example calculation of this shortly. Then the next change happened in 2017 when the sleeping units were added into the code. So as we said, this is when hotel rooms, motel rooms, things like that were started to be required to follow this code. So it's not just your typical apartments and condos that were what most people were focused on before. But otherwise, the rest of the changes in this were, again, just to make it fit to adding in the sleeping units, not just dwelling units. then in 2020, there was allowed in engineering analysis was allowed in the code for airborne sound or structure-borne sound rather than just the tested metrics of the field test or lab test. So that was the addition in 2020. And now we come to our current code, the 2023 Florida Building Code. And the one thing that changed here is all those times when we were looking at this, it just said the lab test and field test, STC and IIC. Well, the metrics for a field test actually are called something different besides STC and IIC. And there are 3 possible metrics for each of them. And they did not previously say which of the 3 you had to meet. So it has now come along and they have specified what metric you can meet, because we were having people that might have a field test and they could meet one but not another. So now it's, well, do they meet the code or not if they're meeting one metric for field measurements versus another? In this case, it's the normalized noise isolation class, or NNIC, for the airborne sound. So that's the field metric that they're looking for in comparison to the STC as the lab test in that case. And for the impact sound, instead of the IIC as the lab test, then it is now the apparent impact insulation class, or AIIC, that is now required to be met if you're looking at the field metric. As well as then, so that was just the standard building code. We also have the residential code in Florida. And it's very similar, but it's an optional appendix. So it is not mandatory unless it is adopted by local ordinance. But the ratings, instead of 50 in the lab and 45 in the field, are 45 in the lab and 42 in the field. And this one uses the, for the field metrics, the same NNIC for the airborne sound, but for the structure-borne sound, it uses the normalized impact sound rating, or NISR, in this case. And then as we actually look at the reference standards in the residential code here, we can see the years associated with these. So the lab tests here, ASTM E90 and E492, have the last 2 digits there after them are the years that those were adopted for those standards were adopted by ASTM. And the last time, again, they have been modified since by ASTM, but the reference standard for the Florida Building Code in this case is 2004 and 2009. So we're seeing about 15 or 20 years old is how kind of old they want us to look at. But we actually see all the time test reports from somebody who they might have tested their wall or the assembly or their flooring assembly with their underlayments in some cases, more than 20 years ago. They might have tested it 35 years ago. And in this, we might actually start to look at, well, it might need to have a more recent test of that product, because over the years, things have changed in how we test briefly, and just the quality of testing itself has changed with our instrumentation throughout the years. Now, the field metrics, the ASTM E336 and E1007, we're seeing those are actually much more recent. They're 2016, 2017 were the reference standards in there. So now we mentioned here the Masonry Society standard 0302 for calculating out the STC rating instead of doing a test. And so they give you different equations. And here we have for clay masonry at the top and then concrete masonry, these 2 sets of equations here. And this is based off of the average assembly weight. So this is the surface weight of everything included in the wall, from the weight of the actual units themselves, any plaster, stucco, paint, grout, mortar, all of it, if the voids are filled, that all goes into it. But if there is gypsum board on the walls, that's not part of this weight. It's just the assembly of the masonry and the associated items for that. There are calculations to include additional gypsum board on this and other equations through here. So. And so actually here we're starting to see some of these the equations to add gypsum board are based only for concrete masonry. They don't have it actually for clay masonry. And this is based off of 1/2 inch or 5/8 inch thick chipboard. And there are a couple of different equations, whether it is on one side or both sides of the wall assembly. And it's going to be whether or not there's sound absorbent material inside the cavity or there's no sound absorbent material in those cavities. And so the things that we're looking at here is actually the thickness of that kind of cavity space or furring space between the block wall and our masonry wall and our gypsum board. So if you have a 2x furring on the wall, that's going to be 1.5 inch space. If it's 1x, maybe you have that 3/4 inch space that you'd use. And then it would be these equations here, if that's on one or both sides with no sound absorbent material. And on this next slide here, we have the equations for if it does have that sound absorbent material like fiberglass bat insulation inside that cavity. You can also do multi-wide masonry construction by doing the composite assembly or the total weight of all of the Ys. To use one of those first equations, 1 or 2, whether it's concrete or clay masonry, those first couple of equations we were showing, it's looking at that weight based on the entire assembly for both Ys or multiple Ys, if more than 2 even. That could be looking at. So in the commentary to the standard, they also give multiple tables similar to these. This is just an example of some that they have in this that are already calculated out for you. So you don't even always have to do all of the calculations if there's a similar enough information. So here we have the nominal size unit, and we've got these at 125 pounds per cubic foot for the block, which should be, what we're kind of looking at here. Let's say we take an 8-inch nominal block wall that's hollow, and we're only getting 48 STC, or an STC of 48. So that alone, as we can see, doesn't actually meet the code minimum of 50. So just building an 8-inch nominal block wall might not meet code. Now, if we go ahead and decide to fill that same unit with grout, we're up at 57. And we're actually then now meeting that code requirement. And then down below here, we have just that kind of list of different furring space sizes, whether we're on one or both sides of the wall, or if we have absorbent material in that space or not. And we can actually see in some of those very small air cavities, we have some of these where it's actually negative values. So even adding something to a wall, depending on certain scenarios, can decrease the STC rating of that wall. Even though I know it seems like you're adding to it, so you think adding more and more airspace, more this or that, will just increase the rating. There are instances where it will actually decrease the STC rating that you're going to get. So we're going to go ahead and take an example calculation here. And so we've got our 8-inch nominal block at 41 pounds per square foot, which is about typical normal weight block here. So next tab. So we find our equation. This is the equation for concrete block. And so we also have our equation down here for we're going to add gypsum board on one side of this with 1.5 inch airspace. So say we have 2x furring and some fiberglass bats in the cavity. Next slide. So we take our 41 pounds per square foot and add that into our equation. And then we calculate that out. Next. And so just our block itself gets about that 48.9 STC rating. So now when we look through the net side of the equation, adding the gypsum board, we take our dimension here, our 1.5 inches, and we solve out this side of the equation. That's our delta rating. And this is going to give us an increase of 6.4. So then we take both of these and add them together, and we get our rating for our wall of 55.3, or in this case, STC 55. So taking this kind of normal weight block and adding furring on the one side with the bad insulation and gypsum board, we could use this wall, but we couldn't use the wall without this furring because we weren't quite meeting the 50.
Thanks, Matt. So, so Matt's been talking about STC, and, we're going to kind of zoom out a little bit more now and look at some other aspects of it. So most of us, when we think of STC, we think of what we have here, sound from one unit going through the wall assembly to the other space, right? And that's kind of common. I think most architects are familiar with this concept and kind of understand, okay, if I have to have a decent wall between spaces, that's what I'm looking for. But maybe something to consider might be the fact that we also get sounds that flank through the ceiling, over the wall, and back into the other unit. Same sort of path here through the doors. Sounds can leak under the floor ceiling assemblies if they're elevated, like shown here. And so what ends up happening even through windows is that you have a space that you're trying to look at and analyze the STC rating of. And we may think of just the wall, but in reality, and I'm not sure if you can see my pointer or not, hopefully you can, we really need to be looking at all of these sound paths. In acoustics, these are what are called flanking sound paths. Anywhere where there's a joint or a juncture between two planes, we need to take a look at that, because if we have a nice, robust wall between two spaces, well, that's great. But if we don't look at all of the details where these come together, then you could have flanking sound go right through those areas of least resistance. And sometimes the flanking noise can decrease the STC performance by 5 or even 10 points. And so you may think that you have an assembly that meets building code, but if it's in a certain situation like this, where there are many, many paths of potential flanking paths, you could be not in non-compliance if you did field testing. And so, this is just to kind of get you thinking about the idea that STC is not just in one dimension or two dimensions. When we think about the STC, we really need to be thinking about, the entire box, the entire structure of the floor, the walls, the ceiling, so that we're addressing all of these potential paths that could decrease our performance. When we look at STC, what is STC? Well, it's basically a single number rating system of how well a building partition reduces sound from one side to the other. And it takes into account sounds that range from 125 hertz to 4,000 hertz. But if we think about this in terms of human hearing, human ears hear from about 20 hertz to 20,000 hertz. And so what the STC rating really is doing is kind of looking at the frequencies that are more in the kind of middle to kind of middle higher frequencies, but it's not looking at the very high and it's not looking at the very low. And so that's just something to kind of keep in mind as you start to think about this and as you're comparing one assembly to another assembly. You could have numbers that appear to be similar, but they could have very different acoustic performance. We also look at the concept of what are called composite STC ratings, where basically, if you have an entire wall that has a door and a window and a wall structure, you're going to have separate STC ratings for each of those components. But you can also calculate a composite STC rating of the entire structure that allows you to account for the area of the wall, the area of the window, and the area of the door, so that you can more effectively understand how your full assembly might work. So looking at this a little bit further, here we have 3 different walls. And if you look at the top, we've got a similar assembly, different STC. We've got an STC 40 and an STC 48. But wait a second, they look like they're the same walls. What is going on here? Like we've got a couple layers of gypsum board on a metal stud and some insulation in the middle. How is there an 8-point difference? Well, if you look, the assembly on the left has 20 gauge stud spaced 16 inches on center, whereas the assembly in the middle is 25 gauge stud spaced 24 inches on center. And so as your metal gauge starts going down, you actually start to kind of lose STC performance. And so therefore, it's really important to pay attention to what the metal gauge and stud spacing are for each project that you work on. And just know that, you know, something as small as that can have a very large impact on the acoustic performance. Keeping that in mind and just knowing that if you have different project type or different structural needs that require different metal gauge and stud spacing, you need to be aware that they will impact the STC performance. Now, looking at the last two, we've got the middle and the right assemblies. We've got STC 48 for a chipboard wall, and we've got STC 48 for a CMU wall. Okay, and so we're looking, and both of those walls, they look a little different. Why do they have the same STC rating? Well, as I just mentioned on the previous slide, humans hear from 20 to 20,000 hertz, but STC ratings only go from 125 to 4,000 hertz. And so when you have something like a CMU block wall, those have more attenuation in the lower frequencies. They're more appropriate for situations where maybe it's a band room or a music space that needs more low frequency attenuation. Those types of walls and various iterations of CMU walls will perform better because the heavier mass of that material helps the low frequencies. But it looks like on paper on the STC rating that these are equal, but they are not. And so it's just something to kind of keep in mind as you are looking at specialty spaces, especially, or spaces where you know there's going to be amplified music or amplified speech that will have more low frequency content. Your CMU type walls will have more attenuation, more sound reduction in those lower frequencies, and will perform better than just a typical metal stud wall. So just something to think about. Go ahead, Matt.
And none of these 3 walls we're showing here meet code for where you're using them between dwelling units or sleeping units is another thing we want to point out. So again, we saw that 8-inch block when we looked at the Masonry Society's calculations came out right around that 48 that we're seeing here. And we're looking at these other kind of, one layer chipboard walls each side. Again, these walls do not meet code to use between apartments or hotel rooms.
Right. This is just to explain the concept. It's not a recommendation for code compliance. So now looking at this a little bit deeper, we have right here a graph that shows a multitude of different floor ceiling assemblies and their performance. If we look at the bottom, we've got 50 hertz to 10,000. These are the frequencies that people hear. And our hearing goes a little bit lower and a little bit higher, but this is a decent representation. But what we see here is all of these floor ceiling assemblies have an STC rating of 55, and yet one of them has a 20 dB transmission loss, and another one has almost 40 way down here in the 50 hertz. And we also see something similar here where one of these walls has a 60 some dB transmission loss, and some of these others have 80. And so what we can see is that, as we kind of slide this marker over the performance curves, you realize that not all STC assemblies are going to perform exactly the same. So again, just something to kind of keep in mind, 20 dB difference is heard as 4 times louder. So you could have an assembly that has the STC 55 rating, but if you have one of the lower performing ones at one of the lower frequencies, and you've got sounds at just that right frequency, you may have a difference of up to 4 times louder than if you went with one of these higher performing assemblies at the 50 hertz octave band. So just something to kind of keep in mind. Not all STCs are created equal. Not all assemblies are created equal. So looking at how STC is actually tested. So we've got a way that ASTM describes in standard E90, where you have the setup in a lab, and we test for sound transmission in a lab. But you can also do this in the field. And this is commonly done. The standard that governs that is ASTM E336. And that is done many times in multifamily housing. If there's any question about building code compliance or whatnot that comes up, these can be done in the field so that you can actually measure the acoustic performance of a building. When we do this testing, we start off and we have a sound source in one room. We call it the source room. And the sound source is played at a high level, usually around 100 dB or so. And it is measured in the source room so that you know exactly how loud the sound is in that source room. And then we also measure in the receiving room. So you have multiple measurement locations in the receiving room so that you are able to get an average sound level of how much sound is being reduced from the assembly that you are trying to test. So there are 3 different metrics for sound transmission. We've got the ASTC, which is the apparent sound transmission class. This is basically taking your field data and then you're essentially normalizing it to a lab test chamber. The test chamber in a lab is a completely non-absorbent, it's a completely reflective room with no furniture in it, nothing. And so you're basically taking your field data, subtracting out all of the effects of the room, and basically putting in a completely reflective room and getting an approximation of what the lab might be. So that's your ASTC. Your NNIC, the normalized noise isolation class, is basically you're taking your field data And then you're saying, okay, well, we might have measured it in one condition, but if we normalize it to a quote unquote standard living room, which has a reverberation time of about 0.5 seconds, then this is what we would expect the sound transmission class to be in a kind of standard living room. So this NNIC is also taking the data and normalizing it, this time normalizing it to a living room. And then we also have the noise isolation class. So this is the NIC, and basically this is just taking the raw data that is measured in the field, and there is no normalization, no nothing. It's just the raw data and looking at that performance. And so that is very specific to the exact room that it was in. If it was a very absorbent room, if there were lots of carpet and draperies and large upholstered furnishings, it would apply to just that room.
And the NNIC, the one in the middle here, is the one that the code now states is required to use if you're going to do a field test. Before, it didn't tell you which of these three to use. Which you can actually see is kind of Keely explained, there's a lot of differences in how we're adjusting these. And so you can see how one could theoretically change enough to no longer meet code or would push one to meet code if you chose one over another, per se. But so to kind of standardize it, they went ahead and chose one of these metrics, and that is the NNIC, because it's trying to say, well, maybe you don't want all these, big heavy furnishings in here, but this is what we see as a standard living room or a standard office or a standard that's kind of that half-second reverberation time. Is so because most people aren't living in sealed concrete boxes. Um, and again, the noise isolation class is a little too specific to that exact, furnishings and that person that might be in there.
Exactly. So I think I kind of missed my little cues to go over here. But and like Matt was saying, just kind of anecdotally, we have seen a number of cases where if we're kind of borderline with one or more of these in the field, one of these may be over the requirement for the building code and one may be under. And so, there have been a number of cases that we have been involved with where, when you're kind of straddling this line of whether you were in compliance or not, it was difficult before because none of these were actually specified. Now it's specified. Now it's the NNIC. So it makes things a little more clear cut. And just to kind of, hit the point home, we want to make sure that the STC is not confused with an IIC. An IIC is impact insulation class. That's for impact sounds. But it is not the same thing as sound transmission class because sound transmission class is airborne. And, just kind of a visual here when STC is airborne. So airborne sound coming from a speaker goes through the building assembly and radiates down into the room below. Whereas impact sounds come from the impact of a heel or of furniture scraping the floor. And that sound is radiated through the building structure and is heard audibly below. But different types of sounds, and they are measured differently in the building code and in our, acoustics in general. So we're going to talk a little bit more. Matt's going to take it over, and he's going to talk a little bit about the impact insulation class.
So as Keely was just saying, and we've kind of mentioned a little bit before, the IIC or impact insulation class, as it kind of states in the name, is impact noises, impact sounds. So whether this is, just somebody walking across the floor, whether it's kids upstairs running around, you're moving some furniture and it's dragging a bit on here, you drop things in your kitchen, so you drop a plate or a pot or pan, things like that. These are the types of sounds that cause impact sounds, as you can think of it. So again, airborne sounds are sounds that start in the air and then hit the building surfaces, whereas impact sounds start as something kind of impacts into that building surface. And again, just a higher IIC number will mean that there is a lower amount of impact sound that is transmitted. So we have less sound being transmitted into the space, typically below, and this gives us a higher IIC. And so a higher IIC is typically preferred in this case, is an improvement in performance. So again, similar to the STC, we can see here a variety of floor assemblies that have, in this case, an IIC of 55. And we have, again, a wide range of sound levels here. In the low frequency, we're looking at 25 decibel difference in some frequencies. And in the high frequency, as much as 35 decibels in some of these cases here. And again, this range is slightly shifted. It's actually moved 1/3 octave band down from what the STC criteria is. So this goes from 100 hertz to 3150 hertz. And again, similar to the STC, we have our lab test and our field test. Our lab test in this case, you can kind of see is this concrete room with a floor in the middle of it. And this machine that's sitting on the floor is called a tapping machine that is used. We'll just explain a little bit more about the machine a little bit later, but the standard test method is, for the lab, is ASTM E492. And for the field, again, same machine, but we're now actually out in the field and we have the standard ASTM E1007. So the tapping machine doesn't actually mimic the sound of a human foot or anything like that. It's not meant to be the same as the footfall. We can actually see here that the hammers that hit from the tapping machine onto the floor is this line we have up above, and the sound pressure we're seeing rises as frequency increases. Whereas this larger area that we're seeing down below in the shaded blue area is more what we see for the actual walker or human walker on this space. And so we can see actually as frequency increases, the sound level or sound pressure level decreases in this case. So, and again, we see this as a decent bit of a change between them. The yellow or orange color here, as we have, is in IIC between 43 and 45 floor ceiling assembly. And the blue is about a 52 or 55. So they're about a 10 IIC point difference. And we can see that the sound levels between them are about 10 decibels different as well, which is heard as twice as loud. Now, the ambient sound level that we're seeing is down here at, and actually this isn't from the tapping machine, these are footfalls from somebody actually walking on these different floor assemblies. But the ambient sound level, kind of the bottom of these peaks where sound would be if someone wasn't walking on this, we're still seeing, even with the IIC of 52 or 55, which is above code minimum, you're still seeing stuff that's 10 or 15 decibels above that. So that's noticeably louder. It's actually twice as loud to 3 times as loud as the sound level when there's not someone walking on that floor assembly. So this is something someone just notice, someone walking above, even if you are doing, in this case, better than code minimum.
Exactly. Code minimum does not mean inaudible. It does not mean soundproof. It just means that you're meeting the code minimum. And many of the luxury residences or ultra luxury residences that we work on for multifamily go above and beyond, very much so the code minimum.
Yeah, and soundproof is not a term you probably want to use in any of these. It's depending upon what sounds, there's all sorts of things. So
Yes.
But so we talked about mentioned the tapping machine. And so this is kind of an image of what this is. And there are these five hammerheads, basically these steel hammers on a camshaft that rotates so that there is a rate of fall of 10 impacts per second. So again, as we said, this is not anything close to what a person walking would be. This is meant to be loud enough that, we can hear it below in even these larger assemblies or these assemblies that do perform better. We still want to be able to hear these impacts through those so we can see and actually measure how well it performs. So this kind of is an even larger impact than what you might normally have, or if you have this happening all the time on your floor, um, there might be other issues. But this is used both in the lab test and the field test. It's the same piece of equipment that's used for either. And so we take the tapping machine and it's put on typically the upper floor, and then the measurements are taken down below for the receiving room. So in this case, you don't actually have a sound level measurement in the upper floor because it's a set kind of impact. It's a set rate of fall. It's meant to create a standardized impact. So you're only actually measuring it in the receiver room. And the receiving room can be and is typically worse when it's directly below. It's typically your worst case scenario. However, when you're in the field, you are able to do it basically anywhere you can hear this sound. It can be measured to get a number for your own information. So say if you're right at the demising wall between two sets of units, and then there's also the floor ceiling junction. Maybe the person who lives directly below is a snowbird and they're not always in Florida all the time. But the person who's complaining lives diagonally adjacent. Well, you can see kind of how loud that is. You still have to meet the code in the worst case scenario in that directly below. Um, but if someone is complaining that might not necessarily be directly below a space, you can do a field measurement to see what that relative value would be for them. And again, so we're going to look here very similar again to the STC is the IIC. These has the three metrics, and this is for the field measures. So first off, we have the apparent impact insulation class, and that similarly again is sealed concrete walls, no furniture. It's meant to normalize this to be similar to the lab test chamber. Now, then we go to the next one, the NISR, the normalized impact sound rating. And this is, again, to the standardized living room of a half-second reverberation time. So we have this, what we might typically have. While we said that in the last time for STC, this normalized, this middle one was the one that code requires. It was actually for the impact sound, Florida has decided to use the AIIC, or the first one we talked about a minute ago, as its code requirement. This does differ from the International Code Council's criteria. So the Florida Building Code and the International Building Code do differ on this if you are working in other states or other jurisdictions as well. And then third is the ISR. Again, this is just the levels exactly kind of as they were measured. It's not adjusting for any reverberation time in the room. It's just how that specific room performs. So we talked about some adjustments that have to be made typically for absorption in the room, but there's other reasons why we may have to make adjustments to a room. And one of those is also the ambient noise or background sound level when we do measurements. And this is for both airborne sound and impact sound. We want to have our receiving room levels from whatever source we're trying to measure be at least 10 decibels above the ambient sound. If not, if it's closer than that, then we have to go ahead and have correction factors in. And if it actually does have correction factors that can limit how much performance we can state that that assembly has, because we can only measure up to that performance. So if you have a really noisy site, or when you have someone come to measure your assembly, if the background sound level is too high, you might actually get a lower value than what the performance of the actual assembly is, just due to the limitations of that test environment, because it's loud. This is why sometimes these tests can occur if it's, not an occupied building or so, or if it's an office building when they're doing it. They may occur at night when everyone's gone, and things like that. Or even if it's under construction and there's a mock-up of a couple units done, you might go in again later after the construction crews finish for the day, so that it's not as loud. You don't want necessarily, or the times when the lawnmowers are going off for the whole apartment complex the whole time. So there's things like that. There's also minimum and maximum volume requirements. So depending upon which metrics needed, but typically the space to be measured has to be greater than 25 cubic meters, or 882 cubic feet, and should be less than 150 cubic meters, or 5,297 cubic feet. The certain metrics are allowed to be measured greater than that upper volume, but the lower volume for your receiving room needs to be at least that minimum. So like a small space, like a small bathroom, can be, very difficult because it doesn't meet those minimum volume requirements. As well as then we have what's called here coupled volumes. So we were talking about these minimum volume requirements and maximum. Well, what if we have a space like this and we're looking to test the tile floor in this kitchen to then the unit that's below? And now we've got a relatively large volume there. Are we looking at just the kitchen volume, or are we looking at this whole kind of great room volume in this case? Because this is a real scenario we've had. One of these volumes, based on it and the adjustments needed, would pass the criteria just at the 45 by the building code, and one of them did not, and was actually 3 decibels lower, or 3 IIC points lower in this case. So in some scenarios, it really is trying to find out what is the volume to use, what's that coupled volume. The ASTM standard does call out typical spaces for coupled volumes, whether they are or aren't, based on certain dimension requirements and relationships to the space. But not everything is as clear cut in some instances in the field as the standard has. So a quick summary of just some design criteria as well, and the various code requirements. We've talked before, the STC and IIC 50 for a lab test is in the Florida Building Code 8th edition. It's also in the International Building Code at same level. The Florida Residential Code is a 45 for those lab tests. Now in the field, they are 45 and 42 in those cases. We can also see, as we stated, the Florida Building Code is the only one that changed the impact sound for a field metric to an AIIC instead of the NISR that is used in the Florida Residential Code, which again is an optional appendix for the residential code. And then the International Building Code uses the NISR as well. The International Code Council a few years back also came out with their guidelines for acoustics, and they set a acceptable and preferred level of 55 in a lab and 52 in the field for acceptable, and for preferred of a STC or IIC 60 in the lab or 57 in the field. So they're only allowing that kind of 3-point drop instead of the 5-point drop from lab to field. HUD has some recommendations out there that if you have similar adjacencies in different units, that you should have the STC or IIC of 55. And if these are dissimilar adjacencies, so say if it's a bedroom to a kitchen or a bedroom to a living room, you might have something rather than a bedroom to a bedroom would be your similar adjacency. Your dissimilar would be, say, your bedroom to your living room of a different unit, or asking for a 55 to 60 is what they recommend. National Association of Home Builders goes ahead and says to exceed HUD by several points just due to the likelihood of complaints. And as we talked with the IIC ratings, still hearing them even at that 55, in some cases, again, you don't just get rid of complaints by doing minimum code. You can still hear these. And just as a reference for STC in classrooms, basic classroom to classroom wall recommended by ANSI S1260 is an STC of 50. And we'll talk on that a little bit when we get to part 3 about the classroom acoustics and the new education acoustic requirements in the code. So what we've been talking here is, again, a greater STC or IIC rating helps to, reduce these values. 45 is our field tested minimum. We move up to 50, which is where lab tested minimum is a 5-point difference is heard as half as loud, or not quite half as loud, sorry. It's the 10-point difference is half as loud. The 5-point difference is noticeably quieter if you're getting an increase in this value, but not quite half as loud. And then when we have a 15-point change, it is 3 times quieter. And then a 20 is 4 times quieter. And these are perceived sound levels. The actual sound power and sound pressure is a different actual ratio than this. But this is how people hear it, as half as loud as a 10-point difference. And again, as we talked about, just because a unique code doesn't mean people don't complain, doesn't mean people don't still hear this. So this is based off of a study, and it's showing, again, if you're an IIC of 30 to 40, which again is lower than code, we have a lot of people who are hearing this, the footsteps above, and a lot of people who are bothered by these footsteps. We go over to 50 to 60, so we're in that meeting code to up to the edge of that kind of acceptable preferred recommendations from the ICC guideline for acoustics. And still about 30% of people are hearing those footsteps above in these from these assemblies. And there's about 8% or so that are still bothered by them. As we start to go higher and higher, we still have people who hear these and who are still bothered. So again, code minimum is good to know, and sometimes that's what you've got to work to, but it is not recommended. You will still get complaints. It is, just very good to know people are still bothered by these, and sound is one of the biggest complaints that you can see in multifamily housing. So as we said, it less than 50, don't even go there. It doesn't even meet building code. And you're very likely to see litigation from that and many complaints. If you're in that 50 to 55 range, there is still possible litigation, especially if you are looking at higher quality homes, or something that's advertised as luxury. And you still do get complaints in this range. If you're really trying to design this kind of nicer space, you're really looking closer to that 60 plus or 60 to 70 kind of range, which can be very difficult to achieve in some, especially for the IIC ratings, depending upon your base assemblies. So before we go ahead,
we'll pause here and just we can take a few of the questions.
Yeah, I see there's a couple still in the chat that we're gonna go ahead and, or in the Q&A, sorry, not the chat. Keep them in the Q&A, not the chat. But
Matt, do you want to talk about the horizontal bracing?
Yeah, so we have one here is, will horizontal bracing affect the STC? And so what we're going to look at is similar to why we talked about the difference in stud gauge and spacing, is the more rigid the wall, the more easy it is for that sound to transfer to that other side. Sounds can more easily move through that. So create the horizontal bracing is providing a bit more of a rigid wall in this case. And so it is something, it might not have the exact impact. I haven't seen too many test reports that call it out from a lab test. To go ahead and say what the exact rating is, it'd be something to have to look into, but it could likely at least have an effect of some sort. Um, and let's see, let's see.
That's another question that talks about, is it true that most common lawsuits in Florida condominium projects are regarding sound transmission, either from adjacent units or external sources? I would say that, for us, we are engaged as expert witnesses for a number of these types of lawsuit cases. Um, unfortunately, yes, sound transmission from unit to unit is a very common lawsuit. Many times there are lawsuits, if it's an older condominium where that started out as carpet and then carpet is replaced with something that, maybe meets building code, maybe it's at 50, but an STC for carpet is in the high 70s. And so when you replace that with something that's 20 points lower, even though it technically meets, it's heard as over 4 times louder. And so people are, of course, disgruntled to say the least, when all of a sudden they went from hearing very little to hearing all kinds of stuff, especially with the impact sounds from that. And so, that's a big thing. We have also seen a number of lawsuits for penthouses that are located underneath rooftop equipment, HVAC equipment areas where maybe the roof structure was VE'd out, or maybe the HVAC isolation was VE'd out, or maybe there was not any to begin with. And you've got penthouse owners who are usually paying a high premium for their units, and if they are right under all of the mechanical equipment for the entire building, you can sometimes have very disgruntled owners. And so that's another common source of lawsuits as well. There are potentially some from traffic noise and other external sound sources, but a lot of them are kind of unit to unit individual owners. We have seen a lot of that. We have another question that says, how does the building department verify or enforce the STC ratings? Or is this only done if a complaint is filed?
So
For us, there's not necessarily there's no code requirement that says, well, you've got to, test X% of the walls or floor ceiling assemblies to show compliance. That's something that is done not in the United States. In some European countries that's done. Many times it is complaint driven, but you do have the opportunity to basically show compliance with Florida Building Code, either by calculations or by lab tests. Matt, did
I
you want to
will
add something to
say,
that?
yeah, I will say that. So we have seen some architects will list in their wall assemblies, their partition schedule, the STC ratings, and they'll even reference a lab S number at times. It's going to vary from what your AHJ is going to specifically require. Now, I've also seen architects put that in there and the values are wrong, or they didn't take into account the stud gauge and spacing. So that might not be something that, an inspector is going to immediately pick up on. But if you have someone like us reviewing that or another consultant, they might actually go ahead and see there's the rating you're putting in there doesn't quite meet. So you've got to be careful with that because again, it is a code requirement, but um, again, they're not necessarily just going testing buildings just typically all the time to see did you pass, did you not, unless there's a reason to think there might not be. Um, we've got here another one about the walls to an adjacent breezeway rather than a corridor or to an adjacent area like a amenities area like a pool or surface parking lot. So while the code doesn't specify that this is for exterior assemblies, something like a breezeway, it's typically at least partially enclosed, really seen as whether that's got just a covering over top of it, the like a roof. You may look at that a little bit more as a wall that you test to and would require. So I think we've looked at that in cases of that, but to a pool area or amenity area or a pool area or parking, if it's, out exterior on grade, it's a little more of a gray area, and that will still depend on your AHJ. Um, uh, let's see.
Okay.
Then,
So I think we've taken a few questions. I think we should probably move on to the next section, and we'll see about trying to answer a few more once we get through part 2.
and if there's still time at the very end of this, we can come back to some more of these as well. And we might have some of these answered by Jennifer and Marilyn while we're presenting the rest. So, thank you.
So part 2, we're going to look at the design and implementation of assemblies to meet the Florida Building Code. So let's see how they can get implemented in projects. So, what are ways that you can achieve a higher IIC? Well, one way that we just mentioned is, of course, carpeting. Though not every space can be carpeted, and most of the time nowadays, especially in residential, people are not wanting to necessarily go the carpeting route anymore. However, it does do a good job at improving the IIC. And like I mentioned, nowadays with all of these condos kind of coming and the older condos changing out carpet for other types of hard reflective material, there are issues. So what are some other ways that we can deal with it? Well, one is floating floors. Floating floors can help to increase the IIC performance, but they can get a little costly. They do take up a lot of space. And if you have a renovation, it can be kind of difficult to accommodate a floating floor, although they are very effective. Floating floors are typically used in places that need oh, thank you. I forgot about that. Sorry, floating floor. I forgot to
Yeah, so
advance the
the
slides.
floating floors like this, again, you're not typically, when we're talking floating floors here, we're talking usually these thicker concrete floated floors or a kind of multi-layer kind of plywood build up on top of resilient isolators. This isn't just kind of your typical installing your laminate floor or your vinyl floor as a floating installation that were, though all that does still have some minor improvements, these are something you might see more around a fitness center or a mechanical room and in,
Recording studio,
yeah, in
someplace
other
where
specific
there's
spaces.
sensitive acoustics.
And and again, even this, we can see that the IIC rating is kind of getting close to, but not even always where carpet can be because of how the IIC tests are performed. Carpet does perform very well based on the frequencies that it's at as well. Even if you might still hear somebody's foot on the carpet, though you might not hear it with a concrete floated floor. And again, as Keely was saying, we can't have carpet just everywhere, even if we want to. I mean, I don't know anyone really that wants carpet in their bathroom per se. Um,
Not
but
anymore.
so you're going to have a hard surface floor in something like this at times. So we do need to look at other options like these. What we see is very common is tile underlayments. And these things, whether it's for tile or for other hard surface floors like wood floors or luxury vinyl floors, we see both these very thin underlayments and we see the kind of thicker underlayments. So the thin underlayments might be only a few mil, I think some are, 90 mils thick, and a mil is a thousandth of an inch. So versus these thicker underlayments, we're looking at greater than a quarter inch. We're looking at, a quarter inch, a half inch underlayment for some of these thicker ones, depending upon the finish and the rating that we're trying to get and the base assembly. All of these values that are being shown on here are based on the kind of concrete slab assembly, which is what's in, Florida. We see a lot of these in condos and in hotels, these concrete slab assemblies. And so it's something we see a lot more of. But the concepts still work for wood assemblies, but the values would differ. So.
Exactly. And so then moving on to other ways of helping achieve higher IICs are resilient ceilings. And whether we use a system that's shown here that includes a wire tie, or if we use special acoustic isolators, we can get varying degrees of acoustic performance just having a suspended ceiling below the slab. So it's a very significant way to improve the acoustic performance, and an option that many people look at. Then we can kind of layer these systems and take a concrete slab and have the acoustic spring hung ceiling, and then also with either thin underlayment and tile or thick underlayment. And so you can improve even further the acoustic performance by kind of layering the acoustic systems. You have to be careful because, each of these systems has an IIC rating in and of itself. And when you start layering them together, they are not additive, meaning,
The
60.
IIC ratings are for an assembly as a whole. Some will give you
Yep.
a delta IIC, like you might see on an underlayment might claim a delta IIC, but you really even can't add that. Even though they call it a delta, you can't add that value to, say, the ceiling value that you have, or the assembly with the ceiling value here, because some of the same kind of frequency area that you might pick up those kind of easy low-hanging fruit points from the underlayments might be also some of the same ones picked up by the ceiling. So it doesn't quite add together. You have to really look at these as an assembly as a whole and not just an item here.
Exactly.
So, and then again, you can go all the way and have a very robust assembly. I don't think I typically see this between any dwelling unit to dwelling unit because it would be quite a lot, but if you really wanted it, you could, I guess. And it has the kind of thicker floated floor and the spring hung ceiling in this case, or resiliently attached ceiling. Now, again, we talked about the idea of floating a floor, say, having a wood floor on top of this, whether it's adhered down versus floated, the floated still does typically perform better over the underlayment than the adhered does. But again, that's a couple points, but that's not quite the same as what we're looking at when we say floating floor in this case. And insulation in those cavities is also preferred to help improve these values. Some of these things can help with both the STC and IIC, like the sound isolation ceilings, but the like the tile floor underlayments or hard surface floor underlayments won't necessarily help with your STC rating, but they will with the IIC. Another thing we need to look at when we look at these is how the little details occur, where the junctions are in this case. And so in this case, if we have the hard surface floor on, say, an underlayment, we're going to look at the kind of sealant at the edge of the wall and under the baseboard in this case.
And we want to make sure that all of the acoustic systems are resiliently isolated from each other, because anytime you have a detail like this, but if these components were touching each other, they would allow for structure-borne vibration to occur. And so that's why, all of these pieces, the floor isn't touching the wall, isn't touching the gypboard. All of these pieces have to be kind of structurally isolated from each other so that you get those resilient layers in there to try to help dampen some of that structure-borne vibration that gets into the assemblies.
So we've got, let's say this, we've got two different underlayments. We're going to call it underlayment XYZ and underlayment ABC. And we have an IIC rating of 50 to 55 that we're getting with the one, but it seems to be a little more costly. And another we see has an IIC rating of 60 to 70, but seems, to be a bit more affordable of an option. And so I know I probably can't really see this when I ask this question of you guys, but how many of you is going to go with underlayment XYZ over underlayment ABC? Well, so now if we go ahead and look at a little bit more information, and we see that this is how these two underlayments were tested. Underlayment XYZ here was tested just on the bare concrete slab and got that 50 to 55. Whereas ABC was tested here with a full spring hung sealing system below to get this higher rating. So that kind of might help to explain why we're seeing some differences, and you can't really just compare these apples to apples because they're not apples to apples in this case. So it's just one of those things that has to be looked into, is just the claim from the manufacturer of, oh, my underlayment gets this rating, has to be looked at a little bit further to see if you're really getting what you need. Again, it's the assembly as a whole that is rated, not a product.
And just for a reality check, this type of thing does happen all the time when we are asked to review various underlayment performances, because manufacturers are allowed to test in any configuration they want. They just have to provide what the configuration was. And not everybody knows exactly how to look through all of the details of the acoustic test reports. And so, this may seem kind of far-fetched of like, we've got these two underlayments, and one of them is really expensive and one of them's not. But the way that they're tested, one of them has a complete isolated ceiling, where the ceiling is doing a lot of that heavy lifting and is the reason why the IIC rating is so high. But you wouldn't necessarily know that just from looking at the IIC ratings when one is 70 and one is 55. So just something to kind of think about, be aware of, that this is something that has to be looked at when you're looking at the actual acoustic performance of various underlayments.
So here we've got a couple of different wall assemblies, and we're looking at all of these based on that 25 gauge metal studs, 24-inch on center. We've got a pretty typical set of wall assemblies with from one layer of drywall each side all the way up to 2 layers each side here. And we see about a 5-point increase in STC for each of these assemblies. And otherwise, they're pretty similar to each other. But now, if we look at, as we talked before, changing the stud gauge and spacing, next, to 20 gauge studs at 16-inch on center, we've dropped all of these. Now we're at 40, 45, and 50. So we've dropped about 5 points. And again, this 5-point change isn't going to be the same exact for every single one. The change between stud gauge and spacing of this, the 25 gauge 24-inch on center to 20 gauge 16-inch on center will not always be 5 points, and the addition of one layer of 5/8 type X gypsum board in this case does not always add 5 points because there are diminishing returns for the additional mass. These were kind of nice round figures here that were close for these assemblies to be used to show. But now we can go ahead and look at a wall assembly where maybe we add resilient channels and another layer of gypsum board, and we're getting STC 60 to 64. Well, that same rating we can get with the 2 layers each side with an isolation clip. And we can get that same rating again with that 2 layers each side of a double stud wall assembly. So again, these all have similar STC ratings and relatively the same amount of gypsum board, though the one does have an additional layer. But what we actually look at is they have different ways of keeping them resilient. So whether it's a resilient channel, an isolation clip, or a double stud assembly. But we also need to know that, as Keeley pointed out, there can be a big difference between wall assemblies that have the same STC rating and their performance in certain frequencies. The performance may not be equal across all of these. So we see with the double stud assembly, we typically reduce a lot more in the low frequencies than we do with the either of the other two with the isolation clip or resilient channels. And again, so with block wall, we've talked about this kind of nominal 8-inch block wall before. It's that kind of mid 40s range here, the 44 to 48, depends on the kind of weight of the block that you have. But if we go ahead and take that same wall, add a little bit of an airspace and separate framing, just insulation, it can be just glass fiber bad insulation, 1 layer of chipboard. We're up to 60 to 65 as our STC rating. So it's a big improvement or so. It's again similar to those double stud wall and isolation clip walls we were just looking at it for the STC rating. But again, because of that mass from the block and the masonry, we're going to go ahead and reduce more low frequency sound in this case. And at least in this case, we have on one side a chipboard finish, if that's what we're looking for. So,
when we're looking at all this, you might think, well, there ought to be a standard. Well, there actually is a standard. But, just a couple of things to think about is, you can't necessarily rely on just the manufacturer's cut sheets or websites with just the single line IIC test result. You want to try to dig a little deeper if possible and get the full acoustic test report. Make sure that it is done by an accredited lab. And make sure that it's the full document. We'll go over a little bit more on this. But there are some things that we have seen are, there are sometimes information sent from a manufacturer that have multiple pages, all from different labs. I mean, back in the olden days, I have actually seen whiteout on some of the test reports. You don't really see that too much these days, but there can be fudging of numbers. And so it's just something to kind of be aware of. Many manufacturers test in accordance with the standards and will happily provide you with acoustic test reports because they know that people who work in capacities such as ourselves will ask for it to review it and verify it. But just something to kind of be aware of that there are the possibility that sometimes these things can be a little difficult to understand or misleading in ways. So, how to tell if the IIC is what you will get. We want to request the product data page, but then you also want to request the full acoustic test report. You don't want just the summary page of the acoustic test report, you want the full report. The full report will actually say page 1 of however many pages they are. They are supposed to be reproduced in full, meaning they're not supposed to give just 1 page of the test report. You should get page 1 of 4, page 2 of 4, page 3 of 4, and page 4 of 4. The test report should be from an accredited lab, and there should also be the exact building assembly, meaning what was the finished floor, what was the underlayment, what were the adhesives used, mortar, grout, was there a floor ceiling assembly? And then you need to take that acoustic test report and basically compare it to what it is that you want to build. Is it the exact same assembly? If it is, you're good to go. If it's vastly different, or even if it's somewhat different, it's going to be kind of difficult to use the test report unless it's the exact same assembly that you would like to use. There are multiple accreditation agencies nowadays for labs. These are some of the main labs that we have seen. NVLab has been around a long time. Some of these others are a little newer. The International Accreditation Service, IAS, the American Association for Laboratory Accreditation, and the International Laboratory Accreditation Cooperation Mutual
So
Recognition.
the International Laboratory Accreditation Cooperation is a mutual recognition act that includes all of these. So it's not its own kind of testing accreditation program. It just recognizes all of these. And the IAS is actually part of ICC's group as well. But all of these are some of the ones that we typically see that are acceptable kind of and accredited labs, depending upon where you may see. There are other accreditation programs that are part of, again, that same mutual recognition agreement, but these are the ones we typically see in regards to the acoustic testing.
So this is a sample of a product data page for a floor underlayment. Matt, did you want to go ahead and take this?
Yeah, sure. I'll go through this. So here we have a floor underlayment that's 90 mils thick, so relatively thin. Just one of these, and you want to just start to look here. I know we said don't rely on just going here, but it's a good place to start to look to get an idea about some things. And if we look, they have information on tests right here. They have 2 bits of data, one from ASTM E989 and one from ASTM E492 in the years 89 and 90. So one, if you're using this today, these test reports are over 30 years old. So you might want to go ahead and look about getting a more recent test report of these values. But the other thing is, what's the difference between these two? One says impact insulation, one says impact sound transmission. Well, when I actually look at what each of these 2 tests are, one is the lab test that's required to be done, and one is the calculation of the lab test. So there's something off here because they should be one value. One is just kind of how to take the data from the other. They both don't have single number values, actually. So somebody, whoever was writing this, either didn't know or was specifically trying to go ahead and put in these 2 other values. We also see this is a very high an IIC of in upper 60s, low 70s here. But for this 90 mil underlayment, that's again, 90 thousandths of an inch. It's a relatively small and thin underlayment. This seems like it's rather high for that. So what is the assembly this is tested on? This likely does have a ceiling with it if it did get those values, but there's even question of the values themselves. So you do have to just be careful when looking at these. And as I said, it's a place to start to go ahead and see what you need to go ahead and do. Maybe there's too many questions or red flags that pop up with it just from the page here. Maybe it's enough that you want to go ahead and look into the full report or look at your next product. And so here we're actually going to take a look at what a full laboratory test report has. This is just a cover page of this one. In this case, we're looking at an STC reports, but an IIC report would be similar. Not all of them have a cover page like this. This is just something that the manufacturers do. Cover page isn't actually part of the report. But if we go to the next page here, we'll have our first page of our reports, and we can start to see a few things. One, down at the bottom, we have NVLAP, the accreditation group that we, again, one of these that we said is one that we look for. We have at the top here, we have page 1 of 4. It tells us how many pages total and where we are in that. And right above that, it has this test ID number. This test ID number is going to be the same on every single page of this report. So I can match up if my page 1 of 4 and page 4 of 4 are from the same test and not looking from different tests. Next, we'll go ahead and look at, even on this same page, we have the description of the specimen. So this has things like the stud gauge and spacing, the exact assembly, kind of detail, the insulation, how even the screw spacing of how the gypsum board is attached to this will be stated in here. So it gets into usually a very fine level of detail, so you can start to see the difference in this. And it's continued on to the next page, that description, because it's a little bit longer than just this. So here we can see that insulation, how that gypsum board is attached. And again, we look at this, we see page 2 of 4 now. So we're just right next page. Our test ID number matches. We've still got our accreditation still showing. All of this is looking good so far and look like it's an actual, good report for this. We go to the next page, and here we have our actual results, our third octave data results, and they even have an overall value. But so we've got page 3 of 4 here, same test number. And this data here in the transmission loss, because it's the third octave data, this is how we can tell, instead of just looking at that single number rating, oh, this is the 63, does it kind of meet similar to those other walls? Or that double stud assembly, how close is it to that? Well, we can look at these to maybe look at a specific, if you have a certain noise source, whether that's amplified music, whether that's a specific instrument or a piece of equipment that we have data from the manufacturer for your air handler for its radiated sound. We can look at that through this level of detail and data to say how much is actually reduced rather than looking at just the overall number, because that might not show the whole picture, as we've talked about previously. And so it will also have here a graph of this, so you can kind of see how it's working and how it's performing. So the blue line here is the STC contour, is what they call it. So based at the 500 hertz frequency is the level that shows you what the STC is, but you're able to be below that contour for up to 8 points at any one location, or at any individual third octave band location, but the total below that curve cannot add up to more than 32. So that's how that STC is calculated. So that's where we start to see some of these, we might have parts that are below this curve, but it might be a different frequency for the same STC rating. We might be above that. And that's how we get that kind of range in here. So then again, the selection of an appropriate STC for your wall assembly or for your floor ceiling assembly is just really the first step in the design of the entire sound isolation system. Because as we looked at it, it's not just this, it's the entire system. So, next slide. It's all of these. It's the flanking sounds. It's going through the wall. It's going through the door. It's going through where the wall meets the floor, through ceiling spaces. All of these are these critical junctures, and every kind of point where this wall meets another surface is something that needs to be kind of investigated and looked at to maintain that isolation. So that STC rating, is important, but if you don't do all the rest of this, then that STC rating might not be what you think it is. And then there's also a few things you might be able to look out for during the construction administration phase of this. How is the drywall actually sealed to the surrounding surfaces, whether that be the concrete floor, the adjacent drywall, the ceiling. We can see in one of these photos, the sealant bead, and the other here in the bottom right, it's actually got a big gap up there, but that's even smaller than the hole for that duct to go through. And when we have these penetrations, these walls, we can even see in one of them, there's insulation kind of sticking out above this wall. So somebody spent some extra money to insulate this wall, but they didn't run it all the way to the deck. They left these big openings for it, these penetrations. And so sound is going to be a flanking path right over this. For all of these things. So it's stuff that you can look out for while you're in the field of, well, that big hole there for that duct to go through, sound's going right through that. That penetration has to be treated. If this is a demising wall, has to be treated by code to maintain the isolation even. Though if it's just another wall in another building, it should still be treated if you're looking at doing all of this for sound reduction. And then we look at resilient channels. But resilient channels can be installed improperly. Only one of these three is not installed properly. One of there is upside down, the one that we just traced, because there is a right side up and an upside down for the resilient channels. And then this one, the screw went through and short-circuited the system because it went too far past the resilient channel and into the stud from the gypsum board. So the gypsum board should attach to the channel and the channel should attach to the stud. But the gypsum board shouldn't have any screws directly going into that framing. So that's can short circuit it, and just a couple of short circuited screws can have a big decrease in the rating of the wall. So you may have designed a wall that was, meant to actually meet the criteria that you wanted to, but installation of things like this can be a reason for not to meet. There are now there's one or two that I know of products that can tap or block this and help to not short circuit resilient channels out there. And then there's others like the isolation clips were designed because of these deficiencies to go ahead and not be able to be short circuited. But they do come at an increased cost and an increased depth, so it takes up more space. So there's different reasons to kind of look at your different choices. So that was kind of part two. We're going to look at maybe a couple more questions for a couple minutes here before we jump into the last part, which is the enhanced classroom acoustics. So.
Yeah, so I see Marilyn has flagged this question. It says, it seems like meeting code minimum would not meet the standard of care. What STC and IIC would meet the standard of care based on your experience as expert witnesses? I would say that this is highly project and market dependent, meaning that, what's appropriate for a, kind of market type or HUD housing, affordable housing, is going to have different tolerances than if you are designing luxury or ultra luxury high-rise residences. We have a vast experience with the whole gamut. But what is kind of expected in the luxury and ultra luxury is just much, much different and would require very high ratings. But even depends on, are these going to be apartments or are they going to be condos? Are they going to be rented? Are they going to be owned? All of these things are kind of factors that play into it. What's the budget, obviously. Some some projects can afford to kind of go the extra mile and are very focused on providing enhanced acoustics between units. But Matt, do you want to
Yeah,
add a little bit?
so with that as well, as Keely is right in that it is very project specific in this, because if you're building a luxury condo versus a market rate apartment is going to have a different response there for what that standard of care may need to be beyond this. And there are other criteria. So you can look at various references, whether that's guideline for acoustics has their acceptable and preferred criteria. There's also some standards out of Europe that have various ratings of wall assemblies, or well, not wall assemblies, but how much sound can transmit between spaces. And they can actually rate, give almost a sound rating to your building, whether it's like an A rating versus a C rating for your building to see how well it's performed. So there's also some Australian standards that we have that we can look at. So it's using the information we have from multiple sources and kind of tailoring it to that specific project. We've got a couple other here. The effect of plywood shear walls are being inserted in newer wood frame apartments, reducing the rating because the plywood can't go on the outside because the inspectors can't see through the rough. So adding a sound or adding plywood like into the middle of the wall does reduce the rating because you ideally want a larger air cavity and not a lot of these mass air, mass air, mass air kind of spaces that create these small air spaces. So that can be difficult to deal with. Some we've seen that have the plywood shear wall on the interior layer of one side of maybe a double stud assembly, but not two, and that can has its own rating. You do have to look at those assemblies very specifically. And there are some that do push that plywood out to the exterior of those shear walls. I know, as you said, it's a little hard to see. So there is that. And then let's see, the Acoustomat type products over gypcrete on a structural concrete slab. Will they produce a similar result to a floating floor? They won't produce the same result as a concrete floated floor or wood floated floor that we're showing with these larger isolators. They do help to isolate the assembly some, and they do provide an improvement. Those types of products that typically go with the gypsum concrete over top, but they don't actually have the same performance as the thicker, larger floated floor assemblies that we were talking about. So the values that might have been shown here don't apply to those specifically. Would European, Australian sound ratings be presented as STC, IIC ratings, or would they have a different rating system with different values? They actually do have different values and rating systems. They have, it's based off of an ISO standard, typically for at least Europe. And so these are going to be a little bit different. So we're going to go ahead and, since we've only got about 20 minutes left, get into this presentation, and we'll see if we can continue on with questions after.
Yep. So now we're going to switch gears a little bit. We've gone over STC and IIC, and now we're going to look at the new code enhanced classroom acoustics requirements. Matt, would you like to start?
Sure. So again, this is actually new to the Florida Building Code as of this edition, the 2023 edition. It's section 1211, and it's entitled Enhanced Classroom Acoustics. It's actually a very short section in the Florida Building Code, but there's a lot more information behind it than what we see. So it just states that classrooms where this section is required, which is type E occupancies, shall comply with section 808 of the ICC A117.1 here. And so again, this is group E occupancies for classrooms. Enhanced classroom acoustics shall be provided in all classrooms with a volume of 20,000 cubic feet or less. So, and then when we actually look at the A117.1, section 808, we have a couple different criteria. So one is the reverberation time criteria for these classrooms. And it can go and be done either through a performance method or a prescriptive method. So the performance method we're looking at to achieve a mid-frequency reverberation time of 0.6 seconds for classrooms with volumes up to 10,000 cubic feet, or 0.7 seconds with those between 10,000 cubic feet and 20,000 cubic feet. So this would be if you have somebody come to measure the classroom to do this. And this is based off of fully furnished, unoccupied classrooms. Uh, is what we're looking at. Versus the prescriptive method that you're allowed is you look at the noise reduction coefficient, or NRC rating, of the various floor, wall, and ceiling surface finishes of the room. And they have an equation to multiply the square footage of each of those surfaces by their NRC rating, add those together, and then for those that are greater than 10,000 cubic feet, that has to be greater or equal to the volume of the space divided by 12. And if it's between 10,000 and 20,000 cubic feet, it has to be equal or greater to the volume divided by 14 is the equation. And so we'll have actually a quick example here to go through. We'll call this a typical classroom here at 28 feet by 32 feet with 10-foot ceilings. And we've got a tile floor, which has an NRC of 0.05, chipboard walls, also an NRC of 0.05, and we've got some ACT ceiling at an NRC of 0.55. So we take a look at this and we calculate out our volume of the space. So our volume of the space is 8,960 cubic feet, or less than 10,000 cubic feet. So we use the first equation and we take this volume and divide it by 12. And that gives us what we need to meet. And that's 746.67 is what we have to meet. Now we take all of these individual items, our tile floor, our chipboard walls, our ACT, and we multiply them by their surface areas. And we get these values respectively. The floor as a 44.8, the ceiling 492.8, and the walls at 60. So again, the ceiling is doing most of the work here because of that higher NRC. But we're going to go ahead, add these together, and we get 597.6, which does not equal or exceed the 746.67. So we have to go ahead, and this does not meet now. So we have to do something else here. What we're going to do is we're going to change the ACT out for a higher NRC ACT, and this is an NRC 0.75. So we've changed that value out for that. And now we get a 776 value, which is greater than 746. So by changing out that ACT, we can show that this room meets the code requirement here. So we have to just go with that higher NRC ACT in this specific scenario. In others, you can add absorbent wall panels to the walls for some area to help to increase that value as well. If you have carpeted floor, it might have a different value than a tile floor. Again, depending upon, you could have a portion of the ceiling as gypsum board and a portion of it as ACT, depending upon if you have maybe an exterior area and a soffit versus the ACT in the center. There's various ways that this can be worked out. But this is if you're going through that prescriptive method. But the prescriptive method does not take into account the furnishings, which you do get if you can do the measured value. And so those furnishings in the room can help to reduce that reverberation time versus the prescriptive method is just the building surfaces themselves.
Yep. So in addition to reverberation time, we also have this ambient sound level verbiage that kind of packs a lot into just these couple of paragraphs. And so we're going to try to go and break this down because there's a lot that this verbiage encompasses. So what this is saying is that basically we have to have ambient sound levels inside classrooms from sound sources outside of the classroom, which would be anything from the exterior. If you're on a site that's by a roadway, or if there's a chiller plant next to the classroom, if there's an airport nearby, all of those outside sound sources have to be accounted for when you're looking at what the sound levels need to be inside. There is a dBA and a dBc requirement. A dBA is an A-weighted sound level. It's the sound levels that, most people are familiar with. It kind of doesn't take into account the low frequencies, but the C-weighted does. And so that's why the C-weighted is higher. And so basically what this sounds, the ambient sound level inside a classroom cannot exceed 35 dBA and 55 dBc during the greatest 1 hour average sound level. So what does that mean? Well, that means that you actually have to measure what the sound level is on the site, meaning an acoustic consultant would need to go to the site, set out meters during the day, and be able to document what the loudest 1 hour average sound level is, so that they would be able to determine whether that 35 dBA and 55 dBc could be met on the site with the facade as designed. So that's one part of this. The second part is looking at sound sources inside the classroom. And so this actually packs a kind of two-part punch, because we have to look at sound sources inside the classroom, meaning what is the HVAC doing in the classroom? The HVAC cannot be above 35 dBA or 55 dBc. So that means that someone would need to analyze all of the HVAC duct runs to be able to determine whether or not the classrooms meet this. And this also means that if you have adjacencies that are louder than a typical classroom, let's say you've got a band room right next to a classroom, the band room is going to have sound levels over 100 dB with the different types of instruments that are typically played. So you're also going to have to make sure that the sound from the band room is reduced to these sound levels as well, 35 dBA, 55 dBc. And these are all supposed to be looked at independently. So this is kind of a big change for a lot of people. However, this is something that is not necessarily new. Many of the DoDEA schools have these kinds of similar requirements as well. But anyway, so as you can see, this ambient sound level encompasses quite a lot in terms of what needs to be done to acoustically analyze how you meet this criteria. If you're working on an existing building with an E occupancy that's a level 3 alteration, then you do have to abide by the reverberation time criteria. And this level 3 basically applies to where the work area exceeds 50% of the building.
So yeah, this only asks then to do the reverberation time. It does not, for the existing building, ask for the ambient noise criteria. But again, for a level 3 alteration of an existing building, the reverberation time criteria must be met.
Yep.
And this is
So
part of the Florida Building Code has adopted this, but it is also from the International Building Code as well, in the latest edition.
And so looking at, there is a standard called ANSI S12.60 that has actually been around since the 1990s and is still being worked on today. I'm actually part of the working group today. Gary Seabine, my father, was part of the original working group for this standard that basically has much of the requirements that are part of now the building code that looks at the learning spaces and what the reverberation time criteria should be and what the ambient sound level should be. The ANSI standard goes a little further and actually does provide STC requirements for various adjacencies, whether you've got corridors or staircases or toilets, music rooms, offices and conference rooms, and other noisy spaces like mechanical equipment rooms or cafeterias, gym, swimming pool, that kind of thing. And does also provide STC criteria for just any adjacent spaces. The ANSI S12.60 has a table that goes over the OITC, which is outside to inside transmission class rating of both walls with windows and walls without windows, and basically says that if you have a site that's really, really loud, over 80 dB for your 1 hour outdoor noise level, you should not be building a school there. And as the sound levels kind of increase, your sound level at 55 or so is much more moderate. Maybe that's found in kind of a rural school. An OITC rating for the walls with windows would be 30 and without windows would be 36. So this kind of gives a general guidance for the acoustic performance based on how loud this sound is, the loudest 1 hour level on site. Did you want to say something?
Yeah, and the ANSI S1260, here in Florida, there have actually been some of the local school boards that have, or local schools have adopted this for the counties. I believe Orange County follows ANSI S1260 as well. So some of these requirements are not new for, as Keely was saying, is we've even been seeing them used in these schools to these levels. But the ANSI criteria, when we look at these STC and OITC ratings, are a good place to look to start if you're not sure where your STC of your wall is between one classroom to another because you don't know how loud the source is going to be in that adjacent classroom. It gives you a good place to kind of say, well, the criteria is asking for the same and they ask you to meet this. So if you don't have specific source data, or if it's just a typical classroom to classroom, it gives you a place to actually look for a reference. Because you might not know every little thing that's going to go on in every classroom of a school when you're in the process of designing it. It's because someone may decide later down the line to change something or the use, but it gives you a good place to design from to meet.
Yep. So I think that about wraps up our presentation. There's a few resources here for you, and we really appreciate your time and attention for bearing with us as we plowed through the 2 hour code course. But want to open the floor for any additional questions. We've got a few minutes left of the session, but again, thank you so much for your time. My contact info and Matt's contact info are below. Feel free to reach out and say hello.
Yeah, we've got some questions here. One is asking if we can show the resources again. So if you can go back to this slide.
Yep.
And these, the ICC guideline for acoustics, we've referenced the HUD study there, it references the values there. And then the bottom three are kind of the standards. So the top two are free that you can find, but the bottom three, because they're specific standards, they are to be purchased from the specific values. Then we have a question, are the inside-outside ambient noise levels cumulative? Example, 35 dBA plus 35 dBA is allowable. So the sound from an exterior source is measured separate from a sound from an interior source, but that's going to be measured a little bit different. So it's they're looked at individually. is how the
And just an FYI, because sounds are logarithmic, they don't actually add together. Like 35 plus 35 does not equal 70. 35 plus 35 equals 38. But as Matt said, yes, the sound levels, the ambient sound levels have to be looked at independently, and you have to get to that 35 dBA, 55 dBc with independent analysis from each of those sources. So ideally, all of those sources are a little bit below, so that by the time they add together, you're getting to that 35 dBA threshold.
Yeah, well, at the moment, I think that's all the questions. We've just got a couple of thank yous in the Q&A, but if you do have any other questions, we'll stay on the line for a little bit. Otherwise, thank you for sticking with us for those 2 hours.
Thanks for all the discussion. Thanks for all of the comments and questions. This was really fun. Really appreciate it. Thank you, everyone, so much.
Thank you all very much. And thank you everyone who's still with us, have been here, either it's 2 hours or all day long. We appreciate your attendance, and we also appreciate your feedback. So when you hang up, you're going to get a survey on your browser. If you go ahead and take 5 seconds and maybe even 3 seconds to fill that out before you depart for the day, we'd really appreciate it. We will also have that same survey in the email that you're going to receive. In that email will also be a copy of all the presentations that you're seeing. So if you weren't able to download it today, you will still get an email from us. So lots of chances to follow up with all of this information. And again, with your attendance, we're going to run a report that's going to tell us when you logged in and when you logged out. So we'll have that information, and it will include basically everything that you gave us. So your member number, your license number, everything that we asked for on the front end, we will have that on the report. So you are all good. All right, so we will do this again tomorrow. And again, thanks everyone for your time, and we look forward to seeing you tomorrow.
We do have one more question I see just popped up. Is there a math formula to determine the STC when using various components, since you cannot add them? There's not one strict math formula that you can use to look at just individual components. There are some that look at the mass law and things like that that can be used, and there are some software out there to approximate the STC, but these are not quite the same as testing in a lab. So,
And if you have any critical issues, best to have an acoustic consultant take a look so that you can actually verify what it is that you're looking at.
yeah, acoustic consultants like ourselves typically have a large library of test reports or have access to manufacturers' test reports that might not be otherwise easily available. So it's always important to kind of review the test reports if you can and see that. I think that's everything. So again, thank you. I think we're gonna head on out.
Thanks,
Thank you
everyone.
all.
Thank you so much.
Bye.
Bye-bye.